Hello. I'm going to call these videos office hours because these are questions that I've gotten through email um, about some of your homework assignments. And um, there's two problems here. One is a double integral, and the second problem is asking us to find the volume of a solid bounded by some surfaces. So I haven't done any prep for these, so this is kind of the same experience you would get by coming to office hours and having me explain it. This first one, um, I'm just going to go through and I guess the first thing I'll do is take this 4 out. And then e to the x plus e to the 3y. It's not necessary to do this, but I think this makes the problem easier to understand what we're doing here. So we can either treat this like a constant when we integrate with respect to x here, and it looks like there's no problems with that. Another thing we could do is just pull that out in front here, so I'm going to do that. I think I like that. And just remembering to close those parentheses, right? So with respect to x first, then y, then multiply it by 4. Okay. Integral of this thing is e to the x, so I'm going to do 2 steps in one. E to the 9 minus e to the 0, which is 1. Again, this whole thing is a constant, so I'm going to say four e to the 9 minus 4 times the integral of, let's see, what's the integral of e to the 3y? So it's not 3e to the 3y, that would be the derivative. It's going to be 1/3. And that's evaluated from y equals 0 to 3. Maybe I'll bring that 4 back out because you can kind of see what's going to happen here. We're going to get another term here. That looks like e to the, well, 1/3. So that's going to be e to the 9th minus 1. So I think the simplest form that I can think of for this is that. WebAssign should accept that, and I would accept that too, certainly. For the next one, we're going to find the volume of the given solid bounded by the cylinder. So this is my cylinder, and the planes y equals z, x equals 0, and z equals 0. So I'm going to draw potentially a few sketches here, but I just want to, maybe I'll draw a really rough sketch, and then I'll make a better attempt at it. So the first thing is we have this cylinder. So x squared plus y squared is equal to 1. That's this shape. This is equal to 1. We also have the plane y equals z. or z equals y. I'm going to draw it like this. So that's this line, z equals y. And this is what we call a cylinder, or it's a plane, but you can think of this as being like a cylinder where we draw that same shape over and over again and then connect it in order to give us the shape of the surface. So I'm just going to do that at these two spots here. So that's a bit tough to see with using this setup here, since it's exactly parallel to it. But anyway, the idea is we have some plane, I guess, facing like this. Right? When x is equal to 0, that's going to be this back wall here. And so it looks like it's going to be everything out in front of this plane here. And then it's also going to be z equals 0 bounded by that, so everything that's on here, I'm guessing everything above this plane here. So this is the shape that we have. This is the resulting shape that we have. So I'm going to make another attempt at trying to draw this. So the back wall here, if we look at the YZ plane, we've got this shape here. So the plane is going to be intersecting with this surface here. It breaks apart right there. And we get this triangle type shape. Right, so that would be a plane intersecting with a cylinder on this back wall here. We have a plane of intersection right here. So I'll go ahead and draw that. And one point that's made here, so the top is going to be the plane. That's sort of the plane cutting around here. But the bottom is going to be this shape here. I also think that this line is going to be a point of intersection here, since the plane is sort of cutting into the floor here. So we'll draw that. And then the last piece is going to be connecting here to here. Sort of how that plane cuts along the cylinder. So you can kind of picture, I just happen to have one here, some can, and then cutting along the side of that, like this, at an angle, and that's going to produce something that looks like that in 3D. That's going to cut along there. So the idea with that one, I think, is that you have that surface on top, and then this is the outside of your cylinder. I think that it's good to draw these sketches in order to figure out what you're doing, because especially for these ones, and it'll only become more important in triple integrals. For the double integral, we have this formula. Right. And this piece here is a small region that we're integrating over. So the way I see it, that region is this quarter of a circle or quarter of a disk here. That's the region that we're integrating over. And then the surface, right, this is the surface that we're integrating under. So this is the volume over a region under the surface. Z is equal to f of x and y. And just looking at this, it's not really clear what the surface that we're integrating under is, but hopefully based on this drawing you can see that this here is your f of x and y. All right, this is your top surface, and this is your, that quarter disk is your region. So let's see, what did this ask? This asked for find the volume, okay. So I'll leave some room there in my double integral for this, but my top surface is z is equal to y. So I'm just going to put y there. And then dA, we can pick, this is our region that we need to integrate over, is that quarter circle. I am not sure what section this problem was in. If it was in 15.2, then we haven't done polar coordinates yet, so I would just call this, let's see, y is equal to the square root of 1 minus x squared, based on this formula. This would be the line y equals 0, and then x would be in between 0 and 1. So that would be one way to do it. Right, so functions on the inside, y is in between 0 on the bottom, square root of 1 minus x squared on top, and x is in between 0 and 1. So I suspect that you could do it this way. My guess is that you could use that this is in the polar coordinate section. So I'm going to rewrite the same thing here, except now I'm going to be talking about y. And I'm going to be erasing this, but r d theta. In this case, r is in between 0 and 1. Theta is in between 0 and pi over 2, so it's going to be sweeping, right, from 0 to pi over 2, and r is in between 0 and 1. Okay. One thing that I need to change is that this y is not in polar coordinates, so I'm going to change that y to be r sine of theta. So yeah, my assumption is that this is what you need to do, since this is a much more manageable integral to do than this one. Okay, so that one, I can put my sine of theta term out in front here, And then what's left is the integral of 0 to 1 of r squared, one from here, one from here, dr d theta. Again, you cannot split this down the middle. You can't just do this integral and then do this integral. You need to do them in the order that they're presented. So we need kind of left parentheses. All right, we're doing this first, then we're going to do this integral here. Okay, this is 1/3 r to the third, evaluated from 1 to 0, so this is going to be 1/3 times 1. I skipped quite a bit there, hopefully that makes sense. And then sine of theta, so when we integrate that, put the 1/3 out in front, this is going to be, let's see, is that negative or positive cosine? Integral sine is negative cosine. Where theta is between 0 and pi over 2. Let's see, cosine of pi over 2 is going to be 0, and cosine of 0 is going to be 1. So, unfortunately, it looks like we're getting a negative number here. So let me see if I can't figure out what I did wrong. Oh, no, I didn't. It's 0 minus, 0 minus 1. What's happening there? Let's see, it's sweeping from 0 to pi over 2. That makes sense. R is in between 0 and 1. And then the surface is z equals y. This is 1/3 r to the third. Integral of sine. Let's see, so I have negative. Oh, sorry, I'm skipping steps here. Right. Just another lesson for everybody to actually write out what you're intending to write out here. So this is negative cosine of pi over 2 minus negative cosine of 0. This is -1, this is +1, this is 0. So it turns out the volume is 1/3. So hopefully that helps you with your assignment, but that's it for this one. If you have any other questions, email me. I'll just keep making these videos as people ask me questions.